You found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey everybody, welcome to Dapper Reacts 78 MicroRNA Disproves Evolution. I am here, of course, with Vishanti, who is wearing a Doctor Strange hat. It's very cool. Now that is a hat that was originally for the production staff on the first movie?
Yes, it was for the 2016 film, and right there on the sides.
Filming locations.
And also on the back there's filming locations, because they filmed it today.
Very cool. Very cool. Well,
gotta flex on them.
Yes. Normally this would be Jackson with Jackson, however Jackson wasn't able to be here this week. Well, this Tuesday. So instead, what's actually going to be happening is we're going to be doing Jackson with Jackson on Thursday, as well as having the premiere. So Thursday is going to be a 2-show day for the Dapper Dinosaur channel. We're going to have the premiere at noon Pacific, 3 p.m. Eastern, and then Jackson with Jackson at 6 Pacific, 9 p.m. Eastern. I do have a little bit of a cough today. I don't know why. It was persistent. Yes, it was actually much worse yesterday. I'm getting better today. So you may hear me cough from time to time, or have a strained voice as a result. My apologies. Sometimes I get a cough. So, Shanti, we are here to take a look. Brand new creationist, whose name I just heard a few minutes ago, but I've already forgotten. All I remember is thinking that it sounds like the name of a man who died in London in 1892. Because it is a very old-timey Englishy name. Like Cornelius Hunter. Is it Cornelius Hunter? I think it's Cornelius Hunter. Yes, I believe it is Cornelius Hunter. So, we have a couple things, or actually now we have 3 things to read here, and then we will get into the drinking rules, and then we will just go ahead with Mr. Hunter's talk. Alright, so first, Roshina non-flocculated Keller for $1.99 says, "Joy is but the shadow pain casts." Well then, I must be due for a whole lot of joy after doing these shows. DM We Do Be Evolutin Wing for $3 sends a super sticker that says, "How's it going with little Shino Iba?" It's going alright, you know. Shanti, is it going alright over there?
Holding steady.
Could be worse.
We did. Yep.
Yeah.
True.
Alright, Roshina non-flocculated Keller for $1.99 also says, "It's Evolutin time." Yes. There was, in fact, earlier a typo in the name of this stream. I did forget an O in evolution. It's true. So, the drinking rules. Now, I have skimmed this, but I don't remember exactly what's said. So, you know, that's pretty typical for me. So I did vet it to the point where I'm like, I think this will work for a Dapper React. But we will be drinking anytime this guy, whose name I'm pretty sure is Cornelius Hunter, but I might not be right about that. So we're just going to call him Corny for now. So anytime Corny says something that's so stupid, we just kind of have to drink in order to, you know, like, cool down our brain. Brain lubricant? Yeah. Not lubricant, coolant. There we go. Take a drink. We will also take a drink anytime he says something that's actually factually correct, that he's not just quoting from somewhere else, but that he's actually has in his own brain. Now, it's a bit hard because this is an edited video, and I can't directly tell if he's plagiarizing something, which he might be. But we're generous with that one. We'll also take a drink if this guy ever tells a joke that doesn't land, or tells a story that we're pretty sure didn't happen. We will also take a drink if well, it's not going to come out because we're just not going to talk about Australopithecus, so we're not going to worry about ad hominid. But if he mentions the political party that was popular in Germany in the 1930s into the 40s, we'll take a drink for that. We will also take a drink if either Vishanti or I can predict what's coming next. We will also take a drink if he cites a source and we check the source, and rather than just failing to support his claim, which is always the case with creationists, if it actually contradicts his claim, that's a Trojan source. We take a drink for that. We'll also take a drink anytime anyone super chats or milestone chats anything to the effect that AIG or a bag of dicks, or super chats or milestone chats anything with any of the 3 kaiju emojis. That's Godzilla, Mothra, King Ghidorah. Also, if you try to make up your own kaiju emoji, it won't work, I promise. We had someone who tried to use a Godzuki emoji, and I don't have one of those, so like it doesn't work. Roshin of non-flocculated killer for 109 says, drink if they insult chihuahuas? You know what, sure. Because we're not going to get any ad hominids. If they insult chihuahuas, we'll take a drink for that. We'll also take a drink if Godzilla or Mothra come by audibly, which might happen. And we will also take a drink for each gifted membership, and we already have 5 from Joshua Geese. So thank you very much. And then Roshin, a non-flocculated killer for 199 says, yeah, drink if they insult chihuahuas. I just didn't point out that it was super chat, so... yeah, you know what? At least for today, we will do that. And here's 5 drinks. I am drinking Hard Mountain Dew Baja Blast today, because it was in the grocery store yesterday, and so I bought some of it. And then I had a live wire and a watermelon last night while I was watching The Boys. So here's 5 drinks. All right. Shanti, what are you drinking today?
Cran raspberry. Or, sorry, ras cranberry.
Oh.
They changed that.
It was cran ras whatever. You know, it was one of those like copyrighted or something. What's weird?
I don't know.
But Silent Tetrapod also just gifted 5 memberships, so we'll take thanks for that. 1, 2, 3, 4, and 5. Off to a good start. Here we go. You ready? Sorry. Will
Yes.
you be more ready in the near future?
Welcome to Is Evolution Compelling? My name is Cornelius Hunter.
I was right. It is Cornelius Hunter. You think that's his actual study? Because I feel, isn't that like a replica of Darwin's study?
Oh,
Trillmix, who's been a member for 18 months, says, I'm 1.5 dozen months old in the channel with the Godzilla. That's true, you are. Thank you. Hey, I still say the decimal system is better than the decimal system. And I know there are some people who are like, yeah, but like, base 6 is better. And you know what? They have some arguments. But I don't think anyone would realistically argue that base 10 is better than base 12. Base 12 is superior. Maybe the Andorians use a base 12 number system.
I don't know.
What I'm going to do is run through a series of snapshots of the scientific evidence to see how does the scientific evidence bear on the theory of evolution.
I mean, you could go with the consensus of all of the scientists who've looked into this, which is to say, very well, but, you know, I'm sure he's going to come up with something different than that.
First one, microRNA.
Here we go,
You've
the
heard
title
of genes.
of the stream.
Genes are usually used to make proteins. About 25 years ago,
We'll take a drink for that. That's true. That is the usual use of a gene.
some particularly short genes discovered. About 20 nucleotides long, if you remember that from high school.
Would you call them jorts?
Yes, we should call them jorts. So it's a little bit complicated in calling them genes because normally the word gene does actually mean something that codes for a protein, but these microRNAs that are produced from these segments of the DNA are not turned into proteins. They actually stay as RNA and help and stay in the nucleus and regulate further RNA interaction with the genome. So they don't really fit the classical definition of a gene per se. So it's a little weird, but I'm not going to really harp on that fact because it's unless it becomes relevant to the argument. I don't think it matters that that's a sort of like a little nuance that he might be skipping over.
Nucleotides. Those short genes are used to microRNAs, and microRNAs regulate the creation of proteins. Slow down, they can put the process on pause. Of course, those microRNAs can't just be on all the time. They can't just be. They need to be regulated.
I do like the jorts with the G option, like it's Jeff. Yes, that is pretty good. Good job, Bob Ali. I like it.
So there are proteins that regulate the microRNA. It's a process, kind of a chicken and the egg thing going on here.
So this is true. Regulation of genes is actually pretty complex, and there are proteins that go across the nuclear membrane and help regulate the goings on in the nucleus. There are RNAs that don't pass through the barrier and are microRNAs that help regulate things. There are proteins that bring in things like methyl groups to methylate our parts of the genome and then leave, and it's the methyl tag that is stuck to that part of the genome. And yeah, it is a really complex thing, and there's a lot of interaction going back and forth with the cell. But the thing is that one of the predictions of evolution, especially when it comes to neutral theory, is that complexity will arise. And I'm going to read a membership milestone chat from Space Dragon, who's at the amniote level and has been so for 3 months, who says, aside from unary, though, wouldn't all bases view themselves as base 10? Well, okay, yes, that is true. All of them would call, the base that they are operating at 1-0. Also, there is a Godzilla, so we'll take a drink. And yeah, it does mean that you kind of have to talk about bases from the standpoint of the base that you use most typically, which is inconvenient, but what are you going to do? But anyway, so neutral theory is basically how evolution works when there isn't any selection. And one of the things about neutral theory is that it can create complexity that is not really adaptive or maladaptive. It just exists. And it can in the future become adaptive or maladaptive if that complexity can be then tweaked to become either more useful for multiple functions, or perhaps if it turns into a liability because the simpler form of some kind of regulation breaks down and all that's now left with is the more points of failure, more complex thing. So the way this works is you originally have a relatively simple system for accomplishing whatever task it is that the organism needs to do, right? So let's say it's like, okay, I need to digest this kind of nutrient. I have a protein that catalyzes the digestion of this particular kind of nutrient. Boom, done. Easy. Okay, cool. Well, what if you have a copy of that gene? That's going to most likely be a neutral mutation. Okay. But what if now one of the copies only does part of the function of that catalysis? And now the other copy of the gene can do the whole catalysis, but this one can kind of do a little bit of it. And then the original one also mutates. So now it only does a different part of the catalysis. But together, you now have two proteins that can perform the same catalytic reaction with whatever nutrient they need to digest. Well, you've gone from having one protein that does one simple task to now having two interdependent proteins.
You're roboting a lot.
Let's see, am I roboting for chat?
Yes.
Oh, that's weird. I don't know what to do about that. And you have frozen, Vishanti. Are you there still?
That's weird.
I says I have a good connection to YouTube. Dapper's not roboting for me.
That's so weird.
I think it's a Discord
You're saying
thing.
that I'm doing it? What?
You're also roboting for me. They should be hearing you robot. That is bizarre. Can you hang up and call back? Hopefully, Vishanti will be back in just a second. I think it's a Discord thing because I'm seeing a bad connection on Discord. We'll see what happens. So I'm going to keep going with the complexity, although I do have a couple things to read here. Actually, one thing to read. Josh McGee's for $5 with their 10th super chat says, there's 10 kinds of people in the world, those who understand binary and those who don't, and that is correct. I agree wholeheartedly that is in fact the number of people and the kinds of people who exist in the world. Vishanti, can you hear me? This is very bizarre. I'm going to try to... Sorry?
Not sure what that was.
I mean, it was a bad Discord connection. It happens. So, but this kind of complexity increasing operation that works on neutral evolution can happen multiple times, right? You can eventually get something as complex as the mammal blood clotting cascade, where there are dozens of proteins that all have to be triggered in sequence in order to effectively accomplish the task of blood clotting, which other organisms get away with one or two proteins. And so complexity on its own is not an argument against evolution, because evolution heavily predicts that organisms simply will become complex over time as a result of neutral evolution. And also, Becca Giustiano, who's been a member for 8 months and is at the tetrapod level, says AIG is a satchel of phalluses, and we will take a drink for that. Thank you very much.
Kyle Pratt says I got the CrowdStreak update.
All right, I'm going to hit play. And I think Vishanti's video froze again. That's great.
You got the proteins, you got the regulators, they're regulating each other. Very, very interesting. Now, from an evolutionary perspective, when they discovered these microRNA genes, the idea, the hope, the expectation was that they should fall into an evolutionary pattern. That is, the microRNA genes for...
So I love that the citation for this, I don't know if anyone can read it because it's pretty small and it's at the bottom of the stream, but the citation for this is Discover Magazine, which I don't know if anyone knows, but that's not a peer-reviewed anything. So yeah. Yeah, that's just nothing. Now, so later on, I do believe he actually does cite some real papers, but I don't know that he does so. I don't know if he'll get to that here. But basically, you should not be citing that kind of paper. That is not the appropriate article. Cite a real article. So, yeah.
Neighboring species should be similar. MicroRNAs for distant species should be different. That's just the typical way evolution works.
Yeah, he's right. We'll take a drink.
Well, it didn't happen that way. It didn't work that way. The microRNA genes conflicted with the evolutionary. Here's one researcher who's looked at this in detail, and he says,
there we go, Nature. There's a good reference.
I've looked at thousands of microRNA genes,
Mm-hmm.
and I can't find a single example that would support the traditional evolutionary tree. The microRNA genes are contradicting the expectations.
So one of the things I want to point out about this is that this was a paper written in based on a paper that was written in 2012. I believe that actual quotation is from the Discovery magazine. So there is that. This whole I can't find anything that actually supports the tree, whatever. That's not from the paper, and it is an important distinction to make. But the other more important thing is that in the 12 years since then, we found out that what actually happened was that it was a sampling error. When these studies were first initially done, we had very low coverage of the number of these microRNA coding sites in the genome. And it turns out that we were getting basically weird signals as a result of very low sample sizes. So what we ended up doing was just getting more samples. And it turns out that now actually microRNA coding regions of the genome, by and large, do align. Now, there's always going to be some areas in which you have like weird signals if you only take a look at small parts of certain classes of genes or other conserved parts of the genome, right? So what I mean by conserved is that natural selection is acting to keep the sequence of that part of the genome within some kind of bound. Now, that's true for microRNA coding regions because the microRNAs are important in regulatory functions. And so they have to basically maintain a constrained sequence. They can't just freely vary. They can't just accumulate mutations at the mutation rate or at the phylogenetic replacement rate. And so, yeah, as Zach B. Hancock pops in and says, the issue is they're only 20 base pairs long, so you miss a lot without high coverage. Exactly. So once we got the higher coverage, we found out that actually most of these fall right in line with what we're seeing. And it's also the case that here and there, you're going to find one or two regions of constrained DNA where you're going to be more similar to a more distant relation in terms of the phylogeny than to a close one, right? So there's going to be some gene in which humans are, actually we know there are multiple genes in which humans are closer to gorillas than they are to chimpanzees. But overall, in sequence-constrained regions, humans are much more closely related to chimpanzees than gorillas. In fact, I'm sure you could find some areas where humans are more closely related to whales or snakes or something. But that's going to only be a very small number of places. Once you get really good coverage, you see that, in fact, you can reconstruct the phylogeny from whatever section of DNA you're looking at, as long as you're getting enough of the various members of that class with high enough coverage. So basically, all this is, hey, when we didn't know much about microRNA and the regions that code for them, they looked weird. Which, yeah, that's true. Vishanti, are you there? Does not seem like it. Rip for my connection to Vishanti. Here's what I'm going to say. Vishanti, if you can hear me, feel free to hang up for now. Try calling someone else and testing to see if it's your voice connection or if it's mine. Because if it's yours, then I don't know what to tell you. If it's mine, then that will be a problem for me for later. So that's concerning. So yeah. I'm going to assume that Vishanti isn't here right now, which really sucks. Because right now, like, I can see that I have a really, really bad connection to the voice channel. So, yeah. We'll go a little bit longer, and we'll see how that goes.
The evidence is contradicting theory.
Yes, it was in 2012 for a little while.
It is a very serious incongruence. That's the term that they use, incongruence. They're looking for congruences. It doesn't match. It doesn't work. It's incongruent. Here's another paper where they're looking for microRNA genes, and the typical strategy for an evolutionist is to use nearby species. If you're looking for microRNA genes in...
And Zach B. Hancock, who, by the way, go check out his channel. It's great. Says, yep, around 50% of phylogenetic signals shows human gorilla more related, and the equal number of press show chimp gorilla as predicted by coalescent theory. Yeah. So there's multiple reasons for this. One is just incomplete linear sorting, right? Where just because of the randomness involved in genetics, some of the genetic sequences that were common to the human chimpanzee gorilla common ancestor ends up as being more prevalent in humans and gorillas than in chimpanzees, and vice versa, right? Like, sometimes that happens. You can even occasionally get convergence genetically if there is some kind of like link. Oh, I am showing that Vishanti has a really, really, really low download speed. That is probably it. Vishanti.
Yeah, I don't know what's going on there.
Yeah, I mean, you're good now. We have a better connection now. You should talk to your ISP. Not right now.
Yeah, I should, because that's not okay.
75 megabytes per second is abysmal.
Ridiculous.
Yeah, no wonder you were roboting. Or conversely, I was roboting. We were roboting. How about that? We were roboting.
Yeah.
First person plural, baby. So, yeah.
Species A, you look at the microRNA genes that are already known to exist in neighboring similar species. Say, okay, they're going to be similar in this. Use the neighbors. That's the whole idea in evolution. Neighbors are going to be similar.
So, yes, in most cases, the neighbors are going to be the most similar, but that's not always going to be the case for every single section of the DNA. There are multiple reasons why non-neighbors might be similar in certain areas, and you can't just ignore those reasons in terms of your model building, which is one of the things that's very frustrating with creationists. Creationists want things to be very, very simple. But if there's one thing that I want everyone to know about biology, is that it's never as simple as you would like it to be. Sometimes it's close enough to being as simple as the model that the model will be fine and you don't have to worry about too much. But you also need to know where the limits of your model are. So, for instance, if the model says that pretty much anywhere we look in the genome, we should find that more closely related species are more similar genetically. But that is a very, very, very simple version of evolution. Really, that's not going to be the case because of more complicated things like incomplete linear sorting, convergence, things like that. They're just going to happen.
Didn't work. It hindered the discovery of microRNA genes.
So I'm going to take a drink because that's extremely stupid and extremely wrong. These microRNA coding sections of the genome were not discovered because people were looking for congruent relationships between them, between different taxa. Oh, and Vishanti roboted again. Vishanti may or may not be here today, guys. Sorry about that. If you were here just to see Vishanti, I understand if you click away. But before you do, give the stream a dislike, if that's why you're clicking away. If you're clicking away because Vishanti is absent, dislike the stream. If you're not clicking away because Vishanti is absent, but you're sticking around anyway, give the stream a like, because I am noticing that we have 104 people viewing, but only 55 likes. So yeah, the discovery of these was not dependent on people looking for a new phylogenetic signal and a new class of DNA, right? They were discovered independent of that, and then they were examined for their phylogenetic signal. And at first, it turns out they had a somewhat contradictory phylogenetic signal back when we had low coverage of low numbers of these genetic regions of, like 20-ish base pairs. Now that we have much better coverage of these regions, and we know about many more of them, by and large, they do actually give us about the same phylogenetic signal as other parts of the DNA. But one of the things I also want to point out is when you only have a 20 base pair sequence, every single mutation is going to cause a big overall percent difference, which means only a few mutations have to accumulate, and you're going to see a very big difference. And also, it's going to be easier for you to accidentally stumble upon a sequence that some other organism already has. So you have the problem of convergence is amplified, and the amount of signal you can draw from these overall is going to be lower anyway, from any small number of them, which is why we need to get the big number of them in order to recover a meaningful phylogenetic signal. Pat from 199 says, several of us nominated Jillian as backup host. I don't know that I currently am looking for a backup host, but I do appreciate it. I think for now, things are probably going okay with just me here. However, if you really hate it just being me, let me know. Let me know by buying 50 memberships. That's how I'll know I need a backup host. That'll be my key.
And so these researchers wrote in this journal paper that they liberated themselves. We liberated ourselves from the conservation requirement, that is, the evolutionary requirement. We decided to liberate ourselves from that. These findings strongly suggest a wide-ranging, species-specific microRNA. What does that mean, species-specific? That
means every species is going to have a different one.
Means different for neighboring species.
Mm-hmm.
Exactly the opposite of what you would expect from an evolutionary perspective. Okay.
So he's right and also being extremely stupid at the same time. So we're going to take a drink. So here's the problem with that. Creationists, including as far as I know this guy, do actually accept limited amounts of common ancestry, right? Creationists typically think that within these so-called created kinds, which they usually identify as at the family level, that there is common ancestry here. Which means that creationism would predict family-specific microRNAomes, if we're going to use that turn of phrase. Which is also not what this was finding. So this is not just a problem for evolution, this would have been a problem for young Earth creationism too. Because if we're going to say that the 2012 lack of phylogenetic signal within microRNAs is a problem for common ancestry, according to evolution, because it's species specific, that's also a problem for separate ancestry as believed by most young Earth creationists. So, Zach B. Hancock says, they also use presence/absence patterns instead of sequence similarity, which is why missingness was a problem. Okay, so yeah, apparently, now that I did not know. So yeah, they were apparently using different techniques than they perhaps should have been, although with a new technique, how are you going to know that, right? So, yeah, this is something that I see a lot. You see someone point out that there is something that, if true, provides a problem for, say, some scientific thing, right? But then it also provides a problem for creationism. So, or they fail to come up with a differentiating prediction, right? So, for instance, one of the things you often see is you'll say, okay, well, if the flood were true, then we should expect lots of fossils in, like, mudstone and sandstone and lots of volcanic ash. Like, okay, but that's not different from the prediction from science. You have to find out where the predictions are different. And so both evolution and young Earth creationism would expect there to be at least a phylogenetic signal up to the family level, if families are where they're kinds. The difference is then evolution would predict strong signal beyond the family level, and young Earth creationism would not predict that. It turns out that once we got the better studies done on microRNA, we did get a strong phylogenetic signal above the family level, so that disconfirms the creationist prediction. But until we did, when we were at this point in 2012, where there just didn't seem to be a very strong phylogenetic signal, that's a problem for both creationism and evolution equally, because neither of them predict species specificity at this level.
Now, I don't want you to leave here thinking, okay, there's this interesting new problem that was discovered 25 years ago, and evolutionists will work on it. Otherwise, we've got this theory that is working really well. The microRNA incongruencies are typical. It's not just microRNA. I give you that example because it's kind of a neat example. It's kind of recent. Oh, cool. Molecular data in general do not support the evolutionary.
I mean, that's just not true. So molecular data would also include things like the proteome. So that's like the sequence of all the proteins. Now, there are ways in which the proteome is harder to get a phylogenetic signal out of. One of the big reasons for this is that synonymous codons, so codons that code for the same amino acid as each other, will not show up as different if you're just doing protein sequences. So you and I could have a completely identical protein, right? So like, I don't know, if we have like, I mean, pick your favorite protein, right? Like whatever it is, lactase, that's a protein. You and I might have identical lactase proteins, but we could code for them with different codons. And in terms of the actual protein that's made, it would be identical. And so it weakens that signal because there are certain mutations that will be captured if you do a genetic analysis of the gene for the protein that won't be captured with the protein. So another great example of this is there's a protein called prestin that occurs in echolocating mammals, specifically in bats and cetaceans that echolocate. And from a protein standpoint, they're indistinguishable. But if you sequence the genes for the prestin that produce the prestin protein, you'll actually find that they very frequently use different synonymous codons because they're independently evolved. So basically, prestin is important in the processing of echolocation data, as far as I understand. I could be a little bit off on that. Double check me. And so, because it's so specific in terms of the best way to do this, natural selection pushed both bats and cetaceans, toothed cetaceans specifically, towards the same protein. But they have about as many different synonymous codons as they possibly could, because there's no particular reason that one synonymous codon is better than the other. Starbrain 5th Super Chat vein for $5 with a allegedly 5th Super Chat says, "Is this still my 5th Super Chat? I kind of like to change my name at some point, YouTube." Yeah, that is really weird. Have you contacted support? They might be able to help with something. I don't know. That is bizarre. Carrie Bronson for $5 says, "Does blank disprove evolution?" No. The answer is always no. In practice, it is always no. No one thing could realistically disprove evolution at this point. Just like no one observation is very likely to disprove like universal gravitation. Could it be disproven in the way we understand it now? Yeah, but it would take a lot of observations of things acting in very unusual. So yeah. Sorry, so going back to the genome. So one thing with, the molecular evidence. So one thing is with protein sequences, you get a weaker signal. You're always going to get a weaker signal, which means that in some cases, you're going to recover a slightly different tree. So it's not impossible for, say, you to get organisms, say, as close related as bonobos, chimpanzees, and humans, and then for the genetic analysis to say that, oh yeah, bonobos and chimps are closer to each other than they are to humans, and humans are closer to both of them than they are to, say, gorillas. And instead check some aspect of, say, the proteins, and then you find that the protein sequence actually says that maybe bonobos nest with humans. That's possible. It's not very likely, and becomes less likely the more distantly related the organisms are. But you do get a weaker signal from that kind of molecular data.
MicroRNAs are not the exception. They are the rule.
They're not even an exception. That's the thing. We still get the same overall phylogenetic signal from microRNAs. It's just we didn't know that when this was starting.
Here's a paper. Evolutionary trees from biological molecules often do not resemble those from morphology. Morphology, that's the visible features, the bones, the muscles. So if you take and you build a traditional evolutionary trees are constructed from the morphological features. You take the fish, the birds, the mammals, and you create an evolutionary tree based on what you see, and you dissect the organisms and build up the knowledge of the design and put them into an evolutionary tree. Now that we've discovered the molecular data, we're looking under the hood. They don't match.
So, okay, that is oversimplified, and part of this is I suspect that this is in fact actually I'm not sure what this publication is, so I'm not going to comment on it. But I will take a drink, because here's the thing: they don't always match for individual proteins, and they don't always match with genetics overall, because there is this thing called convergent evolution. And so one of the great projects that has been going on since like the late 20th century is trying to use genetics to inform what was previously just character-based cladistics, or taxonomy, right? So as a result, a lot of the taxa that were being used and considered valid, even as recently as like the 1990s, maybe the 1980s, are no longer really used, right? Like Insectivora used to be an order of animals in mammalian that included shrews and aardvarks and South American anteaters and whatnot. And it has turned out that being an insectivorous mammal is not really phylogenetically restricted, and further, being a toothless insect-eating mammal is also not phylogenetically restricted. We can't really use those as synapomorphies. And that was at first really discovered with the use of genetics. But then later on, things like the fossil record have backed us up, right? Fossil aardvarks don't look a whole lot like fossil anteaters. And they also, neither of them really look a whole lot like fossil shrews, except in the fact that, shrews are about as basal as a mammal can get. So you go far back enough, and every mammal lineage kind of looks superficially shrew-like. And so we use the genetics to inform us. Because speaking of creationism, there's this phrase that some creationists out there love, that the DNA is a thing that's passed down sperm and egg to descendants. It is the actual molecule of inheritance. It is the actual molecule that definitely changes in evolution. Anything else that changes in the phenotype is downstream of changes in the genome. So the genome is really the thing that we look to as the best evidence for what the shape of the tree of life is going to be. And so, yeah, sometimes if we only have morphology, we don't get it right. But that's just how it happens, right? Convergent evolution is a thing. Sometimes differences in the genome come up in terms of biochemistry, but not necessarily gross morphology. That just happens. Okay, we have a membership chat from Bitcourse, who's been a member for 17 months, and says, that article looks to be reconciling that issue. Yeah, that's another thing. One of the things creationists love to do is cite the first few lines of an abstract. And here's the thing about an abstract. Abstracts are, what they're there for is to give a quick overview of the state of whatever topic you're talking about in terms of literature, but also to set up the problem that you are trying to solve in the paper. So if you just quote the abstract, usually the conclusion that you get is that whatever this thing is that they're working on is some unsolved problem that we're no closer to answering, and it's some huge problem for whatever field they're in. But the bulk of the paper is specifically them providing solutions to the problem, most of the time. And so that's a common creationist trick that you'll see. In fact, I believe Dr. Dan Stern Cardinal has a Creation Tricks episode about just quoting the abstract.
That is a major incongruency. Revolution.
It's really not, though. It was not exactly like a surprise when it turns out that there were areas in which morphology didn't line up very well with genomic data. I mean, that's kind of a thing you would expect to happen here and there. Exactly where it happened was a bit surprising because it didn't happen in most places, which is one of the things that I really want to drive home. The vast majority of the higher taxa that Carolus Linnaeus pointed out are still used today with basically the same organisms being involved. Most of the various taxa that he identified for morphology are still valid to this day. Also, I do like this this Neanderthal skull we got going up here. It's pretty cool. You can tell it's a Neanderthal in a few ways. It's got a very prominent brow ridge, a low forehead. It's got some beveled wear on those incisors, and it's hard to tell from this angle, but it doesn't have much of a chin. So, Neanderthal skull, not a Homo sapiens skull.
According to evolution,
Also, the really, really honking big nose.
molecular and morphological data should agree they don't.
But they usually do. That's the thing. It's just not true to say that they don't. And I don't think that the author of this is leaving it right there. I'm pretty sure that the bulk of this is actually to tell us why this happens in some cases and why in most cases it doesn't, and how to resolve issues when it does. Let's see. LaserFan17 says, surprise for creationists, whales aren't closely related to tunas. They are not. They are no more closely related to tuna than you are.
RNA is just one. Here's another paper. The growing gap between the molecules and the fossils is astounding.
Oh my goodness. It's Alan Fiducia. I'm just taking a drink. Jeez, man. I do not know why it is that, for some reason, creationists love to hang their hat on Alan Fiducia. It's true that he's a crank and that he likes to contradict the scientific consensus when it comes to dinosaurs. But the thing is that his preferred alternative isn't any better for creationists. He also thinks that birds evolved from archosaur ancestors that were quote-unquote reptilian. His opposition to the birds being dinosaurs is not because he doesn't think birds could have evolved. It's because he thinks there's a better candidate for what they evolved from. So he's not providing any actual aid to the point of creationism. But they don't ever quote him when he's talking about his positive alternative to the birds evolving from dinosaurs hypothesis. They only quote his criticisms of the bird to dinosaur transition. Because if they quoted his actual conclusions, that wouldn't be helpful for them. So they basically have to cherry pick Alan Fiducia, and holy crap, do they love doing it. In fact, he actually hates it. Now, to some degree, I don't have a whole lot of sympathy for him because, I mean, he's become a pseudoscientist in the last few decades. So, like, whatever. You made your bed, buddy. You gotta lie down with the other pseudoscientists. But on the other hand, I do find it ironic just how much he hates that creationists misuse his own work. Because he does not agree with them that birds didn't evolve and were always birds. It doesn't really mean anything. Also, Fade to Great just gifted a membership, so thank you very much. We will take a drink for that. Alright, Strawberry, 5th Super Chat, Vane, who's been a member for 14 months, and is at the diapsid level. Thank you so much, that is very generous. Says, my sister and I watched your Sal's Powell video, and this was her review. Quote, it's just a boring guy lying and less boring dinosaur telling me stuff I already know. Reminder that she is a molecular biology PhD student. Well, okay, she's not technically my target audience then, so... I'm sorry you didn't enjoy that video more. I generally try to write these for people who are not molecular biology PhD students. So, you know, hopefully that helps. All right, here we go.
Another paper. There are major disparities between the molecules and the fossils. And solutions to this problem are elusive.
Dude, again, you were quoting the first line of the abstract. Not even the first sentence fully. Oh, no, you are. Okay, never mind. Sorry. I was just looking at the highlighted section, and I didn't notice it went past what he was actually quoting. Anyone who quotes just the first first sentence of an abstract is lying to you. If that's where they leave it. In fact, why don't we see if we can pull this up? Maybe I can actually find this paper. Maybe we can look at the conclusion of this paper. Flying rocks and flying clocks. Disparity in fossil and molecular dates for birds. National Institutes of Health has a copy of it. I hope... Daniel, if I'm mispronouncing your name, I am sorry. Let's see. So there's the abstract introduction. Okay. Let's take a look at the conclusion. As it is unlikely that the oldest fossils of all surveyed clades have been discovered, that's fair, some disparity must always be attributed to gaps in the fossil record. Yes, however, the patterns elucidated here motivate careful consideration of other sources of error. Though often mischaracterized as scrappy, the fossil record of modern birds is now sampled from hundreds of thousands of specimens from throughout the Cenozoic. As increasing efforts have yielded vast numbers of new specimens but failed to reconcile the gap between molecular and fossil evidence, it becomes less plausible to attribute the disparity solely to gaps in the fossil record. Patterns observed in stem/crown comparisons and mitochondrial/nuclear comparisons are not expected to be affected by limits of the fossil record and thus deserve particular attention. We suggest that the magnitude and pattern of disparity observed here should encourage concern for potential systemic bias in molecular dates, as well as proper calibration strategy. So in conclusion, they're saying, basically, hey, maybe the remaining error after you take account of the disparity between the fossil and the molecular data should be accounted for by differences in how fast certain aspects of the genome can coalesce. And that might solve that problem. And in fact, we do know that the, say, autosomal parts of the DNA, the diploid parts of your DNA, so most of your chromosomes, except for the sex chromosomes and also your mitochondrial DNA, tend to have much, much longer coalescence times. And you cannot simply get a coalescence time for the entirety of the genome. So it is true that there's a disparity. And sure, at least at the beginning of this paper, solutions to the problem are elusive, but by the end of the paper, they're suggesting an actual solution, which is to point out that differences in the rate at which various parts of the genome coalesce may account for the differences, and that they need to go back and recalibrate molecular clocks, at least for birds. So, yeah. And also, Zach B. Hancock says, the origin of passerine birds is famously problematic because of the rapidity at which they arose. There's a ton of incomplete lineage sorting. That's actually true for a lot of bird lineages. So basically, after the KPG, there were 4 groups of birds that made it through. There were the paleognathe birds made it through as a big group. And then among the neonates, the passerines, the galloenserae, and then there was one other group who's can't actually remember what it is off the top of my head. But they all made it through the KPG extinction. And they just exploded in diversity all of a sudden. It's also one of the reasons why ratites are so confusing. It's because there's so much incomplete lineage sorting. Because right at the base, there was an explosion of diversity of very initially closely related animals that went on to found what are now fairly disparate groups. And so, as a result, it's really hard to resolve all of those questions. My Unfinished Journey for $6.66 says, Hail Nero, hail Dapper, and hail our robot overlord Vishanti, who is apparently doing overlord things currently. Also, use all your socks to like and share. Yes, all your socks. At first I was thinking like actual socks for your feet, because I recently bought some new socks, and oh my goodness, putting on brand new socks is so nice. Like, it's so... Which I realize kind of makes me like Dumbledore from Harry Potter. And you know what? That's okay. And yes, I know that there are a whole lot of problems with Harry Potter, both in terms of the source of the books, as well as the texts, which are not always as progressive as I might like. We'll say that. But still, that was a character who really liked a nice pair of socks. And I do too. Dinosaur feet get cold too.
Here's another interesting paper that looked at something called a consistency index. I'm not going to go into too much detail here, but the point is these data points on this graph should be up close to the top of this graph.
Gee, 1991. Okay.
At the top is a 1. The consistency index goes from 0 to 1. Each data point is a study of 30, 40, 50 species.
A study of what about those species, though? I don't even... Is this looking at morphological data? Is this looking at the genome? Is this looking at protein sequences? What is this a study of? I don't know. Maybe we can find this one, too. What is this one? Consistency indices and random data by someone. Consistency indices and random data, Oxford Academic. So let's see. Let's actually find out what this is. This study was undertaken to determine a range of a consistency index values obtainable from random data sets. We generated multiple random data sets, random data matrices, each of 49 different... What is this even doing? I don't currently have access to this. Let's see if I can pay the fee to have access to this. That is what I am doing. What I am not doing is going to sci-hub.se to find out if they have this paper so that I don't have to pay. That would be piracy. Don't you do that. Let's see. So, okay, I have paid the amounts. 49 taxon by character combinations for its 30 datasets were generated. So, okay, consistency index value for randomly generated decreased with Tea Time T for $10 says, Dapper, what size socks do you wear? Godzilla Mothra. I have to get the biggest size for the men's category of socks, and even then, what I typically do is I have to only put one sock on each toe, and then that keeps my toes warm, and then I can wrap up the rest of my little foot pad with some like cloth. That's that. Also, there's a Godzilla and a Mothra, so we'll take a drink. Yeah. All right, so I don't even think they actually sampled any real taxa. So, materials methods. A program available on request was written in BASIC to generate binary state data sets with equal probability of 0 or 1 for each character state for use in clinistic analysis. To eliminate simplesiomorphies and autapomorphies from CI calculations, datasets with characters consistent of all zeros or all ones or only a single one were discarded, as were datasets with any taxon exhibiting the plesiomorphic state 0 for all characters. 30 replicate datasets were generated for each of the 49 taxon by character combinations. Yeah, so there were no actual genomes sequenced. So what is this actually a table of? So, okay. I'm trying to find out this. I think he added those red dots. Those don't seem to be in the paper anywhere. So those red dotted lines, I think, are just him making things up. I don't see that in any of the actual. Yeah, nope. None of the figures in this paper actually have that. I can't show you this paper, because it's behind a paywall. There's that. Let's see. Comparison of consistency index values, published literature with 95% confidence, limits of our data sets. So, yeah, I don't know what he is thinking this paper means. Let's see. Direct comparison of homoplasia levels among data sets remains problematic, even with availability of homoplasia indices. They're free of the effective number of taxon characters without a reliable comparative statistic. Best alternative is to judge data set on its variance from a random result. So all this was trying to do was trying to say, okay, this entire paper, the point of it is we need a control for when we're doing things like phylogenetics. What kind of results do we get when we generate just pure noise? Because anything that's more consistent than pure noise can be seen as some kind of positive result. And anything that's as inconsistent as that is going to just be a null result. And so they created a computer program in BASIC way back in 1991 to generate tens of random character states. This is not even genetics. This is just character states that they randomized that don't mean anything. And then they plotted them out. So, yeah, okay, when you use random data, you don't get a nice evolutionary tree. That's true. I'm going to call this a Trojan source. This is extremely dumb. I do not know how this guy thinks that this paper helps him. This is amazing.
And it's looking at how the incongruencies. It's looking at the incongruencies in that group of species.
Yeah, but that's not a real group of species, my guy. Those are completely random data sets. None of that is real. They didn't use any real data. They generated all of their data according to these methods. In fact, there is not a single actual taxon named in here that they used. What is... Oh my goodness. This is amazing.
Want to have very few incongruencies. If there are very few incongruencies, you're going to have a consistency index of 1 or close to 1. What you see is that these data points consistently, pun intended here, very consistently are not even close.
Yes, because they're random. They were generated in order to not be close, to show what it looks like when there is no congruency in a real data set, by providing an actual model of what true noise looks like. Look, I had never read this paper. I still haven't read it, and I'm gonna, probably dive more into it so I can actually give a better understanding of it, because this is just my cursory examination of this. But all of the data was generated randomly. They wanted to do the math on random. Oh, the x-axis is just the number of taxa. Basically, they were trying to figure out what the amount of congruency is between just pure noise when you take into account different numbers of taxa. So, like, do you get more or less congruency with small numbers of taxa versus large numbers of taxa, things like that. Get a couple super chats here. Too Young to Feel This Old for $5 says, listening to stream while getting my blues ready for inspection tomorrow is the only reason I don't want to pull my hair out while doing it. I am very sorry that you're having to get your blues ready for inspection. That is some nonsense. I am glad that I will never, ever, ever have to do that again. So, yeah. I will. Good luck with that. Strawberry 5th Super Chat vein for $2 says, I vote Zach as co-host. Zach, yeah, if you want to come on, you can let me know. Vishanti is, last I heard, currently on the horn with customer service trying to get her internet out. And we're going to be taking a break pretty soon. So, yeah. That would be a pretty good time for Zach to jump on if he wants to. But then again, Savage, Pinnipetasaurus, Cobra, just gifted 5 Dapper Dinosaur memberships. Thank you so much. I'll take 5 drinks for that. 1, 2, 3, 4, and 5. Okay. So yeah, the only thing I can think of is that this guy didn't understand anything in this paper. Like, just reading the first few paragraphs of the methods section should tell you that this paper is not what he thinks it is. Because, you know what? Here's a quick clue. When you're doing a character-based, like, cladistic analysis for organisms, you don't need to write a basic program to generate your character states. You generate the character states based on actual measurements from the taxa under question or under investigation. So, yeah, that should have tipped him off that maybe this paper isn't what he thinks it is. This might be one of the weirdest weirdest Trojan sources that I've seen yet.
The one. And you want to be looking toward the right-hand side because that's the meaningful studies where you have more species in study.
Well, actually, it said taxa because they weren't species, because they weren't anything. They were just random noise, but okay. But yes, it turns out that you're more likely to get less congruency if you have random noise with larger numbers of taxa, which seems to make sense, right? With smaller numbers of taxa, you should just get more similarities as a result of just random chance, on average.
You're looking at 0.3, 0.4, 0.5. Those are terrible.
Yeah.
It's
true. They are.
Talked to a minute ago was kind of some different papers, quotes from different papers. This is more systematic. This is looking at a lot of issues, a lot of studies, a lot of data is packed into this graph.
No, it's not, though. Because it's literally all random noise. Sorry. I know I probably shouldn't keep pausing to make the same point, but it is really kind of baffling the degree to which this guy does not understand this paper. And I don't know if it's intentional or not. You're also enjoying Solo Dapper? We'll tell you what. Let me know. Send me a message on Discord about whether or not you would rather come on or rather not be here. And if you would rather come on, I'm happy to help you on. And if not, if you just want to relax and watch me lose my mind at the absolute absurdity of this guy's understanding of this paper, I mean, I get that too. There are definitely times where I know I could go on and contribute to a stream, but I just want to listen.
And the data are not anywhere close to where the evolutionary expectation. What's the point of all this that I'm telling you?
Dude, I wish I knew. I really wish I knew the reason that you were telling me that random data doesn't fit evolutionary predictions very well. Because I would have predicted that.
Scientific evidence contradicts theory. Of course, I'm just talking about the molecules here. But that's what I've been telling you, that the scientific evidence is contradictory. They're not meshing.
It is really hard for me to get over the idea that someone took a paper basically designed to get the null result, what it would look like if evolution isn't true, lied to his audience about the point of the paper and how the methods worked by implying that this was data gathered from real organisms, and then just said, hey, look, it doesn't match evolutionary predictions. It's just the inverse of when John Sanford wrote his Mendel's Accountant program, which was basically designed to prove that genetic entropy is real, even though we know experimentally and with other simulations that it's really not real. And then, oh my goodness, guys, his simulations show that genetic entropy happens every single time, wouldn't you know it? Yeah, man. That was the point of the simulation in the first place. It doesn't mean anything. The point of the simulation was literally to give us nonsense. And it's what it did. And then they did a statistical analysis on what nonsense looks like. So we would know that if we see it in the future, we can know we have a null signal. Because controls are really important. It's not always clear what a mathematical null is going to look like in a big, complex statistical system, because you're still going to find congruencies. And you can still use math to figure out what the statistical significance of these things are. So by having the data on what a null result looks like, it's easier to recognize in the future. That's an important thing. It's why we have controls in science, right? It's why we do things like if you're going to culture like bacteria on some growth medium in your petri dish, you also have some petri dishes that don't have any bacteria, but that you subject to the same conditions. Why do you do that? Well, for one thing, it's important to know what this medium looks like when nothing grows in it, so that way if it changes over time, you don't attribute those changes to the bacteria, when in fact they're just what happens to that growth medium. Also, if something does start growing in the growth medium that you thought was sterile, that means that there might be some source of contamination in your experiment, which is throwing off the results of your experimental petri dishes, right? So maybe there's some kind of like fungal contamination that got into your incubator. Well, now you know, because the control is growing fungus, so is your sample. Well, that's a problem. And it's easier to detect if you have a control. This is just that, but for statistical cladistics. That's all this is. It's important, but it's not what this guy thinks it is. But that is my cue to go get myself another drink, put some ice in my drink, and I will take a look at what Zach is going on. And I think Zach will probably be joining us. So we're going to take a perhaps slightly longer intermission than normal in order to get Zach in here. And we'll be back, hopefully with Zach, after the break. I didn't unmute, so we'll take another Dapper as a professional drink. That's 2 of them. Hi, Zach.
Hey, what's up?
Oh, just sucking at my job. That's all. So
Dapper is a professional, actually.
yeah, it's true. I do literally get money from this, and I want to say thank you to everyone because apparently I don't deserve it, but you guys step up anyway. And so I want to say that if you can forgive me for things like forgetting to unmute myself, and you're still willing to support, then we have a number of great ways to do that. The first, probably the best way, is the Patreon. That starts at $1 a month. You can get a 15% discount for going annually. There's also the channel memberships that starts at $1.99 a month. Both those have higher tiers if you want more perks. Both of them give you early access to my scripted videos. Both of them give you access to my supporters only Discord server. So that's great. Those are all that stuff that I think it's a pretty decent value. There's months and months worth of content that's just available for early access. There's people who are channel members or patrons. But if a monthly or an annual pledge isn't really your style, you don't want to do that, that's great too. There's always super chats, super thanks, gifting other people memberships. Also, I have a wish list linked in the description for Amazon, where there's books. Sometimes there's like electronic stuff. I think I have a chair on there because this desk chair it's not the greatest. Also, Joshua Geese just gifted a membership. Thank you very much. We will take a drink for that. There's also a merch store linked below this description if you want to show your fandom or fanness, I don't know, whatever noun you want to show that's related to you being a fan of this channel. You can get like Dapper Dinosaur or Mecha Dapper. There's some other designs on a t-shirt, on a mug, on a blanket, on a pillow, a towel, a baby onesie, all sorts of stuff. And if you can't, or you simply don't want to support financially, that is absolutely okay. What I would ask everyone to do is like the video, share this video, maybe comment on the video, watch a few of my videos in a row. So, Zach, I'm not going to ask if you're ready because everyone always says no. Are you going to be able to become more ready in the next few minutes?
I shall. Yes, I believe that's true.
You will be able to get more ready in the next few minutes, so we should wait?
No. I will warm up as we go along.
Oh, okay.
I will become progressively more ready as we sink into this.
All right.
Now, what we're usually told in our biology classes and in our meetings, this is a no-brainer. All the evidence is.
I cannot hear
So
what
the
you're
earlier
saying.
ones that I showed you a minute ago were DNA. This one is more encompassing.
So I do want to point out, Zach, did you notice that when he said that we were going to talk about molecular data, he then brought up a study that was literally simulating character-based data from like a cladistic analysis, not molecular-based data, and it was randomly generated in the first place.
Yeah, I think he's actually quite confused on that, on even the figure itself, because the consistency index of the simulated data was actually higher than the random data, which seemed to me as if it's actually indicating that the model was doing better than the random data. So I think he's just completely confused at what he was looking at.
Yeah. Well, I mean, clearly this guy is not exactly someone who has like a lot of credentials in relevant fields. He seems to be less well educated on this topic than I am, and I have a bachelor's degree in history as my like sole credential. Science Kimono Dragon Nerd, thank you very much, for $10 says, went tide pooling this morning. A sign says, this cobble beach formed over 1 million years. A young Earth group gouge out the word millions. Oh, great. Here's my contribution in the fight against ignorance with a Godzilla. Well, thank you very much. I will take a drink for that Godzilla, and that is really unfortunate. But here's the thing, right? I don't think I would go vandalize a creationist sign. That seems inappropriate.
Yeah, when I was in undergrad, I used to have one of those Darwin sticker things, the Darwin fish stickers on the back of my vehicle. And I was in like a grocery store parking lot and somebody ripped it off.
Yeah, that's really inappropriate. That is not okay. It's also inappropriate to go rip off someone's Jesus fish. Right?
Sure.
Leave other people's stuff alone. This is actively a threat to your safety. You shouldn't go, like, just destroy other people's property. Now, if, like, I don't know, like, their car is barreling towards you and you can stop it by, like, I don't know, erecting a wall earthbender style, okay, sure, whatever, I guess. Seems like an unlikely situation, but in that case, I guess I don't care that much that you damage their property. But, like, generally speaking, leave other people's stuff alone. By the way, I'm switching to Hard Mountain Dew original flavor. So it was
Nice.
just a regular old Mountain Dew with its weird, like, yellowy green neon color. Lady Moonweb, who's been a member for 16 months, says string AIG equals new string bag equals new string 4 bag 0 Matt bag 1 Pam 2 Andrew bag 3 Jeffrey bag equals AIG with a Ghidorah, and I do appreciate the coding version of AIG as a bag of dicks, so we'll take a drink. Lots of nice string data. Aztec Canis Lupus Familiaris Schwauensis Ryu for $4.99 says, that's unfortunately the problem. These people are more willing than their detractors to vandalize. Yeah. It's almost like it's sort of like a criminal version of the bullshit asymmetry principle, right? Like, I don't want to simply say things and then let them go as if there's no explanation for them. And similarly, I don't want to go around vandalizing people's stuff. But apparently, some of my intellectual opponents disagree on both of those things. And it's weird to me. But we're going to hit play.
Here's another paper. Incongruities. I explained incongruities. That's where it's not working. Incongruities can be seen everywhere in the universal tree.
Well, yeah, of course. Zach, what?
But and incongruities also don't mean not working.
Right.
It means that you have, when you sequence different regions of the genome, you get trees. Yeah, like, because you're building a phylogenetic tree from each region that you sequence, and you can have a majority tree. The vast majority of the genome shows one topology.
Mm-hmm.
And we typically think of that as what we call the species tree. This is the tree that most of the genome agrees with. But there are incongruities in other regions of the genome with that tree. And you've talked about it already, but there's lots of things that cause that, including both natural selection as well as genetic drift in the form of incomplete lineage sorting. And so what we talk about when we say incongruities is we just mean not all of the trees agree with what the majority tree shows. That's an incongruity.
Yeah. So, by way of an analogy, in case people need one, I don't know. If you think about it in terms of, like, trying to figure out, like, who's the author of a text, right? So, like, in a lot of ancient texts, we have texts that are supposed to have been written by one person, but it's hard to say if they actually were, because, a lot of people liked to just pretend that the text they were writing was by someone more famous in order to get the text to be more popular. And so we do things like we analyze things like word choice, grammar, style, things like that. But there are always going to be areas where any given author deviates from their typical word choices or styles. That doesn't mean that we can therefore conclude that there's just no way to determine authorship. That comes up actually a lot in biblical studies, right? Like, which of the epistles attributed to Paul were actually written by Paul? Well, you can't just go in and say, oh, this particular passage is atypical of Paul's style, therefore this epistle was written by someone else. You have to look at the entirety of the entire text and see if it consistently tends to not follow the expected style and word choice and grammar and whatnot. It's similar with the DNA. You can't just say, oh, this one gene is more close between gorillas and humans, therefore gorillas and humans are either more closely related, or I guess evolution doesn't work. Like, that's...
Yeah, I think they're also often confused in like these incongruities are biological. Like, they emerge for biological reasons. And so to get a congruity, you have to have two species that effectively find a common ancestor before they are joined by a third species that diverged earlier, right? And so if that doesn't happen, and all three of these lineages are in the same ancestral population before any one of them coalesce, then they start coalescing randomly. And so, like, this is a process that we understand. And so if two species have or if you have a bunch of species rapidly speciating, then you increase the probability that you're going to get these incongruences. And so we have, like, very clear, long-standing theory that explains why these sorts of things happen, and they just act like we don't know why, or that we're just hand-waving it away, when, like, these are things that we've been mathematically modeling since the 1970s.
Yeah, that is another thing, is, like, this is not news. I mean, like, not at all. We've known this for
No,
like half
like
a century.
incomplete lineage sorting, we teach in intro evolution. It's a thing that like we've understood for a very long time.
Yeah. And I mean, you could even see that in some of the dates on his papers. Like, this is from 1998. Like, we've come a long ways since 1998, I promise.
Yeah.
Now, I don't want you to leave here today and think, well, okay, so this guy talked about incongruities in the evolutionary tree. Got some problems in the evolutionary tree. I'm sure evolutionists are working on this. They're going to figure this out. It's a thorn. It's an interesting problem. But otherwise,
Oh, Jillian Estrogen Stress Ren says the 7-year-old says hi. Well, hello. I hope you're doing all right. I hope this stream is still entertaining for you.
evolution is a strong, obvious, compelling theory. The evolutionary tree problem is the tip of the iceberg.
Ooh.
It's just the tip of something that we can get our hands on. So I showed that example.
Just the tip.
Just the tip.
Many more problems. Not the exception, but the rule. Evolution's another way to judge a theory, another way to scientifically evaluate from a dispassionate perspective. And I'm fine with evolution.
Yeah, I'm sure this guy is examining evolution from a dispassionate position. The guy who thinks that his eternal salvation rests on getting things like this right is definitely going to be dispassionate about this.
True, it's not a big deal to me. But a good way to objectively evaluate a theory is to look at its predictions.
I mean, I feel like there are tens of thousands of confirmed predictions of evolution evident in the literature, and that's been the case for about a century now. Zach, does that seem like a reasonable assessment to you?
Yeah, I mean, I guess if I can ask maybe what he thinks the fundamental predictions of evolution are, but I think of them as that organisms are A, capable of changing within populations, 2, that there are mechanisms that cause species to emerge, like for biodiversity to emerge, and 3, universal common descent. And all 3 of those things have been verified numerous times. To me, those are the 3 fundamental predictions. I don't know what fundamental predictions he thinks have failed.
Yeah. Also, I have added Zach's channel to the description. So, you go check the description, you'll see a link to both Vishanti's channel and Zach's channel. So, if you haven't subscribed to Zach, go do that. All right, here we go.
Look at the predictions that have been made. Now, we've had 150 years since Darwin, so we've had a lot of predictions from evolutionists.
That's true. I'll take a drink for that.
Had some time to check it out. Evolution, the predictions from that mainstream consensus evolutionists have made failed over and over again. And I've documented this on my website called
Okay, good, because I'm like, do you have an example? Like, come on, man.
Darwin's Predictions. That's just a resource for you. I'm not.
The DNA code is not unique. Correct? I mean, it's shared by virtually all organisms identically. That seems like a prediction of evolution, though, but okay.
All those. There's about 22 predictions on there that are major, fundamental predictions. These are not tangential predictions that have been made over the years that are
competition is greatest between neighbors,
and they have failed.
Sorry, say that again.
There are just weird things listed here, like evolutionary cause predictions. Competition is greatest between neighbors. Mutations are not adaptive. Like, what is he talking about here?
Yeah, it's it's very, very odd. Like, mutations are not adaptive. Well, I mean, some of them are, but they're not like induced for adaptive purposes.
Oh, you think that's what he means?
I think that's what he means. Is that for some reason he thinks that evolution would predict that mutations are induced because they're adaptive, as if it's like. Yeah, but that's not true. We know that's not true. We've known that for 80 plus years. Longer than we've known about genetics, per se. Yeah,
I mean, I guess in Darwin's day that might because he went back to 150 years prediction. So I guess if we go all the way back to Darwin, who did believe that the environment could induce change, then maybe. But I don't know. We definitely haven't thought that since at least the early 1900s.
Yeah, and even the limited ways in which the environment can induce change with things like radiation or mutagens causing mutations, it doesn't cause directed mutations. It just increases the overall mutation rate.
Yeah, it doesn't bias them towards being more adaptive.
Yeah.
Unambiguously. Good resource. If you Google Cornelius Hunter and Darwin's predictions, it'll come up. It's a complicated Google URL, so Cornelius Hunter, Darwin's predictions.
Cornelius.
Now,
Yeah, I don't know if you were here at the very beginning, but I was telling Vishanti that his name sounds like the name of someone who died in London in like 1892.
Yeah, I was, with that name, I was not expecting such an American accent.
Right? Yeah, it sounds like he should have like a received pronunciation accent. And,
Yeah.
It seems like he should be someone who like traces his ancestry back to like some minor nobility in like rural England. And
I bet this dude is like super proud of his family tree. I bet he has like an ancestry.com. He's definitely done.
You think he's one of those guys who's like, yeah, well, one of my many times great grandparents came over on the Mayflower, so.
But he's definitely that person.
Okay.
when you have a failed prediction, what do evolutionists do about it? Well, sometimes it's just, we're working on it, hold on. But oftentimes what they do is they'll address that problem by modifying the theory.
Zach, isn't that just part of science?
Yeah.
Last I checked, I'm just going to take a drink for this. Oh my god, they modified their theory to account for new data?
Yeah, I don't know how they think ideas come about and how theories are formed, right? If like a theory is only a good theory if it can completely be constructed without ever seeing a shred of evidence beforehand. It's like that's like science is built by doing experiment and then we formulate the ideas from that. Like,
right? That's
just how it works. So we have to be able to update with new data where we don't like this isn't not trying to tell the future here in Nostradamus style.
Yeah, look, there was a time when things like natural philosophy proceeded by people just sitting around and thinking. And you know what? That wasn't completely useless, right? Greek philosophers did figure out some pretty cool stuff just by thinking about logic and how the world had to work logically without going out and then testing. They still got some stuff right. There were also times when they did go out and test things, right? Like when the Greeks decided that, well, Earth is probably round. And then, you get like Aristophanes, who's like, well, I'll bet I can measure it. Sticks and the sun. And he did. Yeah. And he got within about 10% of the actual value given how crude his instruments were. That's pretty good. Yeah.
Aristotle did a lot of dissections and stuff.
Yeah. So, like, there's been a lot of progress, but now we're not at the point where you can just kind of sit around and think about science and then it just kind of works. Even when we get to people who are famous for thought experiments like Einstein, he was basing those thought experiments on already known observations, right? So when he's like, well, what if you're in an accelerating elevator? Guess what? He'd been in an accelerating elevator.
Right.
Einstein had ridden in elevators. He knew the kinds of things that happen in them, right? So, like, yeah, this is one of those things.
I'm also wondering where he's fixing to go. Like, he just put this word simplicity up in front of us, but it's not really played into anything that he said so far. So,
yeah.
Here's where he's going to go with this.
Yeah, well, I will hit play after I say one quick thing, which is basically creationists consistently like to say that they are fans of science, that they like science, and then they consistently have some of the most anti-science attitudes that you could possibly have, that it's conceivable for a person to have. And so they're just, I don't know if they're lying or they just don't know what science is or if it's both, but they are absolutely not pro-science. It's hard to conceive of a way they could be less pro-science.
Got a false prediction? Oh, okay, we got to tweak the theory. We're going to change a few things.
Yeah, that's science, my guy.
And so evolutionists have been busy changing the theory consistently for years, updating, modifying. Oh, we got a new thing here.
Yeah, good.
When Darwin proposed the theory 150 years ago, it was reasonably simple. In the meantime, it has become more and more complicated, and that violates a fundamental philosophical rule for science, which is you got to keep your...
That is not a philosophical rule of science. What is happening? Sometimes the truth is complicated, and so you need complicated explanations for it. Like, is he... Okay, yeah, William of Occam's razor, entities should not be multiplied unnecessarily. Yeah, but you can multiply entities when it is necessary. So if your current explanation needs more entities, you have to put in more entities. Strawberry, 5th Super Chat fan for $5 says, just gonna go scream into a pillow for young Earth creationists complaining that science does exactly what it's supposed to do. Yeah, if you have a why is science on your bingo card, this would be a great time to fill that square in.
I I think this is a gross misrepresentation of evolutionary, like the history of evolutionary theory as well. Like we've had, like evolutionary theory has been pretty robust, starting in the 1930s and 40s, and all of the key mechanisms of evolution have been discovered for 100 years now, since at least the 1920s. We've added no new mechanisms of evolution since then. All that we have done is added the complications that the biology demands. And so if it turns out that we know a lot of genes are interacting with each other, then we need to generate mathematical models that can tolerate that can account for that sort of thing. If we know that fitness is something that changes probabilistically, then we need to include probability theory into our mathematical models, right? And so we're not tweaking it because we're proven wrong. We're learning new things. Turns out nature is complicated. Mm-hmm. And so we try to model it as best as we can. But the core theory is still exactly the same. We've just built upon that core theory.
And also, Max P just reported a bingo. So congratulations to Max P. I think you have the first bingo. All right, here we go.
Over the years, over the centuries, philosophers and scientists have pounded this home. Simplicity, simplicity, simplicity. You must not allow your theory to become complicated.
No, it's more complicated than it needs to be. It's an important distinction. That's why Occam's razor says unnecessarily. Some things just are complicated, and you're not going to be able to adequately describe them in simple terms. Right? Even things that you think you already know. Could you describe to me the rules for the ordering of adjectives in English when you want to apply more than one adjective to a noun?
God, no. What?
Did you even know that there were rules for that?
The me 30 seconds ago didn't.
Right. There actually are. There's a strict hierarchy of adjectives, and they fall into certain categories, and they have to come in a particular order, or native English speakers feel like it's weird and wrong. And the rules are actually somewhat complex.
I feel like I intuitively know, I feel like if somebody used an adjective in a weird fact, I'd be like, that seems wrong, you should switch that. But I definitely didn't know that there was a specific rule for it.
Yep. And here's the thing. There's a lot of stuff like that that's very complicated in language. And if you want to adequately describe the grammar of a language, such that someone can come to this language with a grammar book and a lexicon and successfully construct new sentences, it's going to be a complicated thing that you have to do. Anyone who's tried to learn a language will find this out, right? And even after you think you have a good grasp on the grammar, there will be subtle things like that are different. For instance, unlike English, French requires that basically all the clauses in a sentence have the same tense. That's not true in English. In English, you can kind of mix and match things. If some of the action happens in the future, but some of it, you can still use the present tense in some of the clauses, even though the action's happening in the future in English. It's not that strict. Yeah. French is. Most French students don't figure that out for quite a while. It's similar with anything else in science. If the phenomenon is complex, you may need a complex explanation for it. You want to keep your theories as simple as they can be, because otherwise you're just introducing complexity for no reason. But they don't have to actually be simple in some objective sense. Right?
Yeah. We always try to explain what we see with the simplest possible terms first. And then if we can't adequately explain the data with simplicity, then you add some level of complexity until you can explain the data, or until you find out that you've overfit your model and you just actually don't have a good model to explain this data. And sometimes that happens. Yeah. But in general, we always begin with the simplest possible model, especially in statistics, because you're penalized by adding more complexity to models in statistics. And so you want to describe it as simply as possible. So that's the principle we go by. But sometimes, as you said, you just have to make it more complex, so you're not actually capturing what's going on in nature.
In fact, I would argue that that's directly what this Albert Einstein quote is saying. Everything should be made as simple as possible, but not simpler.
Exactly.
And in fact, Einstein himself made versions of Newton's equations of motion that were much more complicated because he had to, because he was dealing with physics at levels and energy levels where Newton's equations stopped working well. They stopped adequately describing the phenomenon that he was investigating. So he had to come up with more complicated versions of it. So, I don't know, maybe Cornelius here is going to also complain about relativity. I wouldn't put it past him. I've seen creationists do it.
Well, that's exactly what's happened with evolution. I'm just going to run through a bunch of examples here of how the theory has become more and more complex. You've heard of gradualism. Now we have punctuated equilibrium.
Hey, I'm going to take a drink. Zach, you want us to talk about punctuated equilibrium real quick?
Oh, God. What have I done? Why did I join this?
I gave you an out. I said, if you'd rather just watch, you can. And you specifically sent me a message so that you could join.
But when I did that, I did not foresee this moment. I did not foresee that punctuated equilibrium. I should have, though. This is on me. You know what? This is on me, actually.
Yeah. Look, anyone who voluntarily comes on one of these shows needs to expect it to be the worst thing possible. But Zach, give us a quick version of your take on punctuated equilibrium.
So punctuated equilibrium is an idea that originated. Gosh, I'm going too deep here. Punctuated equilibrium basically is the idea that that evolution does not proceed in populations, but it proceeds when populations split. And so the vast majority of all evolutionary change is what we call cladogenetic. So when the populations are dividing, but when you have a single sort of population, there's very little to no evolution happening. This is often not how popular people have presented punctuated equilibrium. They present it as this kind of stasis and then rapid change, but still within modern evolutionary theory. That's actually not what punctuated equilibrium was, and Gould rolls over in his grave every time people do that. Punctuated equilibrium was a new theory of evolution that challenged the modern synthetic view of evolution. So it actually was something that was viewed by him and by Niles Eldredge as radically transforming the way we think about evolution. Spoiler alert, it's very wrong. It's actually been falsified many, many times. We don't use this model anymore. Now, that's not to say that we don't use models of stasis and rapid change, but those things occur within the existing paradigm that we understand. It's not actually some brand new paradigm. And in fact, during the big debates in the 70s and 80s over punctuated equilibrium, a lot of population geneticists were like, dude, this just sounds like Soule-Wright shifting balance theory, which has been around since the 1930s. And it just seems like Gould and Eldredge didn't actually read top gen theory before they came up with it. So I have a whole soapbox. Forgive me, everyone. I've actually written a paper on this. It was one of my first sort of history review in the literature kind of paper for the 75th anniversary of the publication of the journal Evolution. They invited perspective pieces. And so we actually wrote a paper on punctuated equilibrium for that. So I have a whole soapbox to stand on.
Also, if you want a fuller video version that doesn't require you to go read a whole paper, Zach has a whole video about that.
That is true. I have an entire video dedicated to the history of punctuated equilibrium, why it has been grossly misused. Not just by creationists. Everybody misunderstands it. Just trying to dispel some of the myths and show that actually it's not what people think it is. And we should really. The only reason that it's still around is because Gould was such a good popularizer, and honestly, a very talented communicator and science writer. Don't get me wrong. But he also popularized this idea well beyond what it would have ever lasted in reality if it hadn't have been for that.
Yeah. All right, I'll hit play.
You've heard of descent with modification? Now we have
Yes.
species-specific biology. You've heard of natural.
What does that mean?
That is not a contrast. Saying that a species is unique, which is the only thing I can think that means, that's just how we figure out that it's a species. If a species isn't unique, it's probably not a species.
Yeah, I don't even know what the last slide was trying to say.
I'm just gonna take a drink. So I'll try to. I'll give it the only interpretation I think I can, which, based on my history of being able to successfully determine what Raw Matt was saying, I'm just gonna say that I have a pretty good talent when it comes to trying to figure out what creationists mean. So here's my drink.
Okay, I'm gonna defer to you here.
So I'm very confident that what he's saying is that because certain species have unique characteristics that are not shared by any other species, that is a failed prediction of evolution, which, according to him, should predict that no species should be unique. Which is extremely wrong.
So he just doesn't. Okay, he just doesn't get it. All right.
Yeah. Oh, and here we go. Natural selection, genetic drift. I mean,
no.
to be fair, adding genetic drift is more complicated, but it's also just true, so we kind of can't just ignore it.
Selection.
Also,
Now we have
I don't know if he's gonna. I'll let him say what he's gonna say first, but I do have something to say on this.
Okay.
genetic drift. You've heard of common descent?
Oh, well, that's it.
Oh,
It just
yeah,
points out
yeah,
that they both
nothing-
exist.
Cool. So just quickly then, Darwin actually mentions at least a concept that we would call genetic drift. He does talk about how there could be traits that had no impact on survival and so could just kind of fluctuate through the population. He didn't quite use that word, that language, but that's effectively what he meant. So he had some concept that there were traits that could exist in organisms that natural selection didn't act upon, right? And that they just kind of randomly moved around.
Yeah.
But by the at least by 1920, I'm pretty sure that's when Wright's paper was out. I think it was in 1920. We already had an idea of genetic drift. So, in a mathematical sense. So I don't really know why he thinks that is some sort of complicating factor. It's a statistical fact, right? It's that when you have finite sampling schemes, you have variances around means. And so when you're finite sampling a population every single generation, you have chance fluctuations. Like this is just like basic statistics. And so I guess that is a complication and that it makes the math more difficult, but like it's also like just a fact of nature that no population is infinite. Right, so the only way to not have drift is if it's an infinite population.
Right. Which, again, not real.
I love that he pictured Kimura and showed the neutral theory of molecular evolution there, but like Kimura did not come up with genetic drift. That was around long before he was even born.
Yeah. He did a lot of work in genetic drift because, neutral theory is very, very closely connected with the idea. But yeah, I mean, I guess if you had to pick one person to be your representative guy for genetic drift, I'm not sure who else I would pick, but like,
yeah. I mean, I would pick Sol Wright because it was originally called the Sol Wright effect, which is kind of funny. R.A. Fisher used that as a sort of derogatorily because R.A. Fisher was like a super adaptationist, and him and Sol Wright fought a lot. Sol Wright was like genetic drift is important, so they called it the Sol Wright effect. But
Go ahead, sorry.
Oh, but what like Kimura did is he actually like introduced a lot more of like the more rigorous mathematical treatments of genetic drift. So a lot of the like stochastic equations that we use today are thanks to Kimura's derivations. And yeah, Kimura sort of placed genetic drift as a important part in molecular evolution, a lot more than anybody before him had. So I think in popular sort of like who popularized genetic drift, it's definitely.
Yeah. And also, while you were talking, I was looking at this this diagram for inaccuracies. And I did, in fact, spot some inaccuracies around the arthropod branch. So, for one thing...
yeah.
The spiders,
maybe it's really old?
It would have to be pretty darn old to get this wrong.
Yeah. True.
So, yeah, in case you're wondering, spiders should be the most basally branching group there. They should branch before crustaceans. And also, insects are crustaceans. So it's not a meaningful distinction there. But also, centipedes and millipedes should branch before the crustaceans and insects. So basically we have a decapod. The decapod and insects are the most closely related on the arthropod branch. Then comes centipedes and millipedes. Then comes spiders. So we've definitely got the shape of the arthropod tree wrong. Command Cyborg just joined the channel at the Sauropsid level. Thank you very much, Command Cyborg.
I think this must be old because it still shows protostomes and deuterostomes divisions, and it still shows the pseudocoelomates, which hasn't existed in a long time.
Yeah,
and
that's a good point too. Yeah,
and nematodes are actually more related to arthropods, with annelids should be more related to mollusks. So this has just got to be like an ancient tree.
Oh, I didn't even notice with the nematodes.
Yeah, those should be switched. Well, actually, brownworms are just totally at the wrong place. They're like below coelomates, but really they're like secondarily pseudocoelomates, which people don't even like to use the word pseudocoelomate.
Well, get a better chart, my guy.
Now we have common.
What does that mean? Also, convergence has never been at odds with common descent. Ever. Like, ever. The whole point of convergence is that you have to have some kind of common descent somewhere. in order for the evolution to occur that can then converge. I'm going to take another drink. This guy is bafflingly dumb about this.
That Lamarck was wrong. Well, now Lamarck is back.
Okay, I know you have a soapbox about neo-Lamarckism and things like epigenetics.
My gosh, I do have a soapbox. I'm so sorry. I have too many soapboxes.
No, that's why you're here. It's why I was like, yeah, sure, you can come on.
Oh my gosh. So yeah. For those that, I'm sure everybody knows Lamarck, but basically Lamarck's idea is that the environment could induce changes in organisms that could be adaptive, right? So instead of sort of what we would call random mutation, and by random we just mean that there's no foresight. It's not trying to be adaptive. Whether or not it's adaptive in the given environment is chance. But like that's typically how we think about inheritance. But in this sense, Lamarckism is quote unquote back in basically a sort of epigenetic sense, in that since the environment can cause these sort of epigenetic markers that can then be passed on to future generations, then perhaps epigenetics is a kind of quote unquote neo-Lamarckism, right? There's a massive problem with this that's 100 years old, in that if you're interested in the adaptability of any organism, a good place to look is organisms nearing extinction, right? The ones that are really struggling, where like conservation concerns are, and you're dumping a lot of money into trying to save these populations. And we're really concerned about these populations because they can't adapt to their environment. And the reason that they can't adapt to their environment is because they have very, very low genetic diversity. And so if epigenetics was the thing that was like a dominant player in evolution and in adaptation and was going to, rescue these populations, then there should actually be no correlation between the ability of a population to adapt and how much genetic diversity they have, right? Because epigenetics is independent of genetic diversity. However, as we all know, if you take a agricultural crop or a dog or whatever, inbreed it, remove all the genetic diversity, and then expose it to a new environment and try to get it to change, it won't. Right? It will simply not change because it doesn't have the diversity to do so. Despite the fact that it can have epigenetic change because the environment is different, it still will not be able to adapt. And this is something that's been known for like 100 years. We've done these like purebred mice experiments and crop crosses and like all these sorts of things going back to like Wilhelm Johansen in the early 1900s, and found that if a population has no genetic diversity, it cannot adapt to the environment. So to me, that's like the death knell to Lamarckism, and they thought that's the way they viewed it as well. So this is a weird sort of contrarian rewriting of history that people are trying to resurrect Lamarck when he should stay dead.
What I usually hear is like, haha, the Weissman barrier has been technically breached by epigenetics. Therefore, who knows? Lamarckism is back. I'm like, no.
It's also very silly because we've known about maternal effects for like 60 years, and maternal effects also breach the Weissman barrier. But maternal effects have been
the Weissman barrier real quick.
Oh, that's true. Again, since we're talking about Lamarck, the idea was that the environment could induce heritable change, not just change in your body cells, but could induce change that gets passed on to your offspring. And Darwin actually believed. He had what he called was pangenesis, is this gemmule idea that your body was exposed to environmental differences, and then like these little gemmules sort of collected the information and then would carry it down into your germline, and then you would have offspring that could change by the environment, right?
Because information is stored in the balls.
Yeah. But Weissman rejected this. Weissman instead said that the soma, your body cells, are distinct from your germ cells, and the two don't talk. The germ cells will give rise to all the rest of your body cells, but the body cells do not influence germ cells. There's this barrier between those two things.
Which is
and he actually showed this with like it's not as strict as he would have thought. But he showed this with a really kind of morbid experiment where he severed the tails of 68 mice over 5 generations, and showed that their offspring always had fully formed tails.
Yeah. All right, here we go.
Of the evolutionary tree. Now evolutionists are talking about pluralism, pattern pluralism.
So that's just horizontal gene transfer at the base of the tree of life. It's
Is that what he means by pattern pluralism?
It's the only thing I can think of. Because when you see this headline, evolution, Charles Darwin was wrong about the tree of life. The tree of life is being politely buried. What's less accepted is the whole fundamental view of our biology needs to change. That's what they're talking about. They're talking about the fact that when you get to the widest taxa, like archaea and bacteria and eukaryota, it's hard to come up with a resolvable tree because of the extensive amount of horizontal gene transfer going on very early on at the base of the tree. Yeah. Which means that finding out exactly how closely related two different groups are in this area is complicated because significant amount of their genomes were transferred not from ancestor to descendant, but from one organism to another, both of whom were currently alive and who exchanged genetic material that was not just incorporated into an offspring, but into the present organism as horizontal gene transfer. And yeah, that's true. That does make things more complicated, and it does make the naive branching that Darwin was thinking about incorrect at the very base of the tree of life. But that's not going to get you to things like humans are a special creation unrelated to chimpanzees, which is one of the complaints I have about a lot of creationists. They will look at things that are so far away from their actual problems with evolution that it barely even makes sense to talk about, right? It's like, okay, you don't think humans and chimpanzees have common ancestry. I don't care what you think about the common ancestry of bacteria and archaea and eukaryota. Like, hold up.
Yeah, like honestly, if you accept common ancestry of those three domains, then like, okay, then evolution is obviously true and explains at least the vast majority of every living thing, right? Like, then we're basically done talking at that point.
Yeah, it reminds me of one time I heard a flat earther talking about how gravity must be wrong because, and then they started to go into like measurements of the speed of objects around galactic disks and having that speed curve being too flat when compared to the predictions of Einsteinian gravity. It's like, hold up, dude. You don't think that things even fall because of gravity. You are not at the point where we need to be talking about like velocity curves measured in distant galaxies. Back up. We have much more basic problems that we need to address before we talk about this problem. And it's the same thing here.
Yeah.
As one evolutionist put it, tree of life is being politely buried. What is less accepted is that our whole fundamental view of biology needs to change.
It sounds like one of those extended evolutionary synthesis type guys.
It's either that or it's a Gould quote.
Yeah.
You've heard of random mutations. Now we have directed mutations.
Do we, though? So I'm going to take a drink, because here's the thing. Every once in a while, a paper does come out saying, oh, hey, we think we have evidence for directed mutation in organism X. And then a whole bunch of people go out and repeat these experiments or come up with new experiments to test this idea. And consistently they find that, nope, sorry, that was an incorrect conclusion. Maybe it wasn't an error on your part. Maybe you just had data that, as a fluke, came out with looking like induced mutation that was adapted. But that's just generally what happens, is other people try to replicate the results and can't. And it turns out, nope, there was never actually any evidence for this in the first place. Is that...
Yeah, almost always they're technical errors. I think the most recent one was the Arabidopsis paper.
Yeah, I remember that one.
Yeah, so that one was kind of like the more recent headline, and that one had just a lot of actually bioinformatic errors. So it's kind of complicated to like explain exactly like the issues with these sorts of things, but there's a lot of like sort of bioinformatic things that go on under the hood, a lot of computer programming that goes on under the hood, and you can mess things up. It happens. And that's why we have the peer review process. That's why anytime you see a brand new paper that claims something big, just wait. Just give it some time, and people will try to rerun their analyses, and people almost always find problems. Just about any time this sort of thing comes up. It's also possible that or another kind of silly thing to me here is that, let's say mutations are directed. Let's say there is a bias in the direction of adaptive mutations. That doesn't hurt evolution. right? Like that doesn't harm universal common descent at all.
Right.
At best, it means that we need to tweak some of our numbers in like the way that we model mutations presently. And we actually have lots of models that account for mutation bias. Like most phylogenetic models account for the fact that transitions occur far more likely than transversions, right? So like purine to purine versus purine to pyrimidine, those two changes occur at different rates. And like we model this all the time. And so if it were to happen that you had directed mutations, okay, so what, right? Like that to me doesn't actually challenge evolution in any way.
Yeah, it certainly doesn't challenge the parts of evolution that this guy objects to, which is mostly universal common descent. Which is similar to when he was earlier quoting Alan Fiducia, right? It's like, look, if Alan Fiducia is right, that doesn't help you. It's the same thing with this. If directed mutations are right, that doesn't help you separate humans as their own special boys of biology, which is ultimately what this is about, right? They want to make sure that humans aren't genetically related to other organisms. That's their biggest goal.
Yeah. And there's like a lot of like really good work on mutation bias being done right now. And like we're reevaluating the way we model mutations and the way we think about mutations as we have learned a lot more about sort of the underlying molecular biology. But there is nothing that we have discovered that is like fundamentally challenging the basic population genetics that has existed for us.
Yeah.
For the Darwin said, nature does not make leaps. Now we have leaps.
Saltationism has never been supported. Ever.
Yeah.
I'm just going to take a drink.
This is also another one of those, I'm not gonna do a soapbox, but this is another one I have a soapbox for. Darwin's understanding of the way evolution worked is dramatically different than the way we understand it. Darwin believed, right, that the environment induced change in organisms directly. He believed that in like a blending style of inheritance, that was only rescued by the environment effectively adding changes. And he believed that natural selection would only work on very, very, very slight differences between individuals, and so must be very slow. We don't actually think like that anymore. And like we haven't thought like that since basically we rediscovered Mendel's laws, right?
Yeah.
And we've realized that actually mutations are discrete things that happen in single steps. They're not these like continuous gradual changes like Darwin viewed them. And so in many respects, sort of the emergence of Mendelian laws and sort of the convergence of Darwin's natural selection with Mendelian laws of inheritance overturned a lot of the way Darwin would have viewed evolution. So they're taking this quote that he's saying here and they're applying it to the modern way that we think about leaps in evolution, not in the way that Darwin specifically meant it.
Yeah, and I also want to point out
I have a whole soapbox on it, sorry.
The classical version of saltationism, an actual example used by macromutationists, was that like maybe one day a crocodile could lay an egg that hatches into a bird.
Yeah, and that's
never been supported. Yeah, it's not a thing.
And even the early mutationists who were sometimes like derogatorily called saltationists did not think that was the way it was. They just thought that like, okay, you have a red flower and then one mutation can cause it to be blue. Like to them, that was a big leap. And even Darwin did not believe that could occur. He thought it had to transition smoothly through all colors in between. So like that was what they were debating. And I feel like that's just been completely taken out of context.
Agreed.
Saltation. Sort of evolutionary mechanisms. Now we have the unknown mechanism.
What?
Yes.
What does that mean?
I don't know.
Okay.
It's so small I can't read it. What the hell is it
Lateral
supposed to
transfer of tetrahymenol synthesizing genes has allowed multiple diverse eukaryote lineages to independently adapt to environments without oxygen.
That's not an unknown mechanism. That's the mechanism.
Lateral transfer is right there. It's horizontal gene transfer. Okay. I'm just going to take a drink for the unknown mechanism is horizontal gene transfer, which is,
I see.
Unknown
what
mechanism.
He's trying to say, I think what he's trying to say here is it's laterally transferred among phylogenetically diverged eukaryotes through an unknown. The unknown mechanism is just the biochemical mechanism.
Oh, like specifically, how did this organism receive this DNA from this other organism?
Exactly. That's what it seems like he's referring.
That's not an evolutionary mechanism. That's a biochemical mechanism, and those are not the same thing. Okay, well, that's Thanks for not knowing the difference between biomolecules, biomolecular mechanisms, and evolutionary mechanisms. It turns out you can understand one and not the other. And either way, right? Like, you could understand the biomechanical causes of something, but not the evolutionary causes. And conversely, you could understand the evolutionary causes of something, but not the biomolecular causes. Like, those are independent things that we could learn about separately. They're obviously connected, but you can understand one and not the other. That's fine.
Yeah. A great example of this is the entirety of the ENCODE project. That you could have a bunch of biochemists and molecular biologists that knew a lot about molecular biology, but not a damn thing about evolution.
Yeah, exactly. So we're going to get a little bit more of this guy's talking, and we're going to start wrapping things up. I'll start talking about what we have coming up soon on the channel, and then we'll be out of here.
Talk about the unknown mechanism. On Tuesdays, it does this. This is not science. You have a theory that has just got so many moving parts and so many special cases. Every new finding becomes another special case.
Well, first, no, that's an exaggeration. And second, biology is complicated, my guy. I don't know what to tell you. Sorry. Living things are not
by
simple.
its very nature, it's going to be more complicated than like physics. Like, really and truly, right? Like, biology is so much more complicated than physics. It's more complicated than chemistry. We just are working with bigger, more complicated things. It's just like the way it's the nature of it.
It turns out that emergent phenomena are more complicated than the simple phenomena from which they emerge. That's just... I'm sorry that's just kind of how math works, basically, is what this comes down to. Is this guy is objecting to the fact that emergent phenomena are complex compared to the things they emerge from. But that's just how it is. All right,
not being the other way.
Yeah, it's mathematically impossible for it to be any other way. I mean, you can think about a very, very simple example is like Conway's Game of Life, right? There are multiple patterns in Conway's Game of Life, like gliders and oscillators and glider guns and things like that, right? None of those are encoded in the rules on which the simulation operates. The simulation has 4 rules and a grid. That's it. And yet, when you combine all these rules, you can get complicated emergent phenomena. That glider in Conway's Game of Life that forever goes off at a diagonal angle into infinity is not easily describable by just stating the rules of Conway's Game of Life. And yet, it still emerges from them. And that's true for cellular automata generally. You can actually make all sorts of different cellular automata simulations. You can write a much smaller list of rules than you would expect to get the very complex behavior. Strawberry 5th Super Chat Vein for $2 says, biology is complicated, therefore it's not science. That does seem to be his overall conclusion, which is quite the take. All right, so Zach, what do you have coming up on your channel that you think people should know about?
Goodness, what do I have coming up? What I've been working on actually is a full rebuttal of this particular character that's been making the YouTube rounds named Dennis Noble. Dennis Noble is a famed physiologist. He's really well known in like the physiological circles. But recently he's come to fame after doing like a debate with Richard Dawkins, and he is a proponent of what is known as the third way of evolution. It's kind of like new age evolution, right? It's like the kind of the woo version of evolution with crystals and stuff. Like, it's that silly kind of thing. He believes that organisms evolve on purpose and that they direct their own evolution. And he was recently featured in a Forbes article that was titled "Scientists are freaking out because it turns out evolution happens on purpose." And this was just utter nonsense. So basically what I'm going to do is spend some time showing why Dennis Noble is a crank and why people should not listen to him. And that's what I got coming up.
Okay, let's take a look at what's coming up on this channel. So tomorrow, actually not on this channel, but on my Top Hats Off channel, we're going to be doing the 4th from the last episode of Power Rangers Jungle Beasts. So if you want to come say hi to me and Bent and TD Lane and Zerolon, who's often in the chat, Tirirana, who's often in the chat, as well as Maddie from Science Side Up, who's on with Maddie. Stop by over on Top Hats Off. That'll be at 6 p.m. Pacific, 9 p.m. Eastern, assuming everyone can make it, which they better. That is the plan for tomorrow. Then on Thursday, we actually have 2 shows at noon Pacific, 3 p.m. Eastern. I am premiering The Messenger of Science, Evolution is a Fact, Part 1 of 5. Basically, I will be taking a look at a live stream by 2 Muslim apologists, Sabur Ahmed and the Muslim Lantern, whose real name I do not know, so I will call him by his screen name. And they are basically going to give their take on why evolution is false from an Islamic point of view. And they are extremely bad at it. Extremely bad at it. It's actually the same live stream that ended up with Sabur Ahmed giving a fake challenge to Professor Dave. I was actually working on this around the same time that he was discovering the live stream, which we did actually talk about just a little bit on the live stream that he and I were on R&Ra's channel. So if you go to R&Ra's channel and check out the Deplorable Ilk live stream that had me and Guts Gibbon and R&Ra and Professor Dave, we mentioned this thing that's coming up. But then later at 6 p.m. Pacific, 9 p.m. Eastern, I'm going to be having Jackson with Jackson. Jackson wasn't able to be here today, but I still wanted to do Jackson with Jackson, so rescheduled it for that day because, of course, I couldn't do it tomorrow because I've got the RPG. Then on Friday, there's nothing, but on Saturday, we're going to be doing a follow-up to this, and I am going to hereby say that, Zach, you are welcome to come on for that. I will also be inviting Vishanti, and so we might have 2 people if Zach is up for it, which you don't have to be. It's fine.
Which day again? Sorry, I was coughing.
That'll be Saturday at noon Pacific, 3 p.m. Eastern.
This upcoming Saturday?
Yes, like the one that is in less than a week.
Yeah, so I will be at the big international conference on evolution this Saturday. This is our big once-a-year conference that the Society holds, which I'm giving a talk at. I'm presenting some of my work. Excited about. So I will not be able to be there, but I will be. I will be doing science. Yeah. Okay, that's probably more important, honestly. So there you go. No Zach, but I will be inviting Vishanti back. Hopefully her internet gets fixed. She has called her ISP, and they are apparently going to be sending out a technician because her 75 megabytes down is ridiculously low. So there you go. And then on Tuesday, so a week from today, we will be doing Kent with Bent. So there you go. And that is bringing us out a week from today. And so I hope that everyone has a wonderful rest of your week. I hope to see all of you on Wednesday for the Power Rangers Tabletop RPG Let's Play, as well as on Thursday for both of the shows. And if you're interested and you have access to the Discord channel, we are going to be going off and watching a few 4 episodes of Power Rangers Mystic Force, just for fun to hang out. And if that's not your thing, that's great too. So everybody, I hope you're all well, and I'll talk to you in just a day or 2.
Before you leave, I just want to take a second to thank my patrons and channel members, especially those pledging $20 or above. Ben Tovin, Phil Ravara, Tapioca Weasel, Whispers, John Ackerman, Strawberry Vein, Dr. Tapioca Weasel, Elaround Teller, Horseflesh, Ian Chen, Kelvin Brostick Van Manen, Landon Knoll, Mabdy Babbity, Sphincter of Doom, and Ballus. It's because of my channel members and patrons whom you're seeing on screen that this channel can stay afloat. Without you, it would all shut down. If you want to join the team, there's a link to join the channel below this video, and there's a link to join the Patreon in the description. On the Patreon, you can get a 10% discount for pledging annually, and either way, you get early access to virtually all of my scripted videos, often 3 to 5 months before they come out for the general public. Thanks for watching.